Law of Gravity by Christian Patel. The vocabulary words. Magnet, a body as a piece of iron or steel that passes the property of attracting certain substances as iron.
Gravity, the force of attraction by which terrestrial bodies tend to fall towards the center of the earth.
Mass, a body of coherent matter, usually of independent shapes and often of considerable sizes.
Weight, the amount or quantity of heaviness or mass, amount a thing weighs.
And distance, the extent or amount of space between the two things, points, lines, or etc. This is showing how gravity affects mass equally. This is the moon, and that shows that the moon has a mass of 3,400 kilometers, so it has enough mass to form into a sphere. And this one is one of the moons of Jupiter, and it only has 18 kilometers of mass, so it doesn't have enough mass to form into a sphere. This slide is showing how this right here shows that gravitational forces weaken as the distance between the masses increase. So as these two are closer together, the gravitational force is greater, and as these two are farther apart, the gravitational mass is weakened. And gravitational force is weaker between objects that have small matter. See, these ones are from the same distance apart, but this one is smaller matters, and the gravitational force is stronger when two or more objects with more matter. This one has more matter than this one. It's 2 times those ones, so the pole is stronger. Alright, this is talking about gravity in outer space, and it's a lot, so I'm not gonna read all of it, but this is showing how the moon is right there. The moon is right there, and it's the gravity of the earth is pulling it towards the earth, like this red line, so that it doesn't drift outwards. But it also has its own gravity, because it has mass, and that's what keeps it circling around the moon, but not going off because of that red line that keeps it towards the moon. And this right here, that's a satellite, showing how the Earth's gravity pulls it down, again with the red line, but it also goes around the Earth, because see, and this is showing how it's going forward. So if it's going forward and it's pulling down, that's how it goes around the Earth. Now this one is showing us how, see right here, this is a person's on the Earth, and they weigh 1,685.5 or 0.6 newtons, and on the moon they would weigh 280 newtons, because weight is affected by gravity. If your weight on the Earth is going to be a lot higher than your weight on the moon, and over here the mass stays the same, because gravity affects objects' weight but doesn't affect the mass. The end.